everyone, this is your Suraj Kumar. You are watching the channel TSK Tutorial. In this video, let us discuss about the lenses. In this video, let us cover the topics lenses, ray diagrams, and some questions on the topics of lenses. What is meant by a lens? A lens is an optical device that focuses or disperses a light beam by means of refraction. That means a light ray can focus or goes away, that means disperses from a lens or an optical device with a phenomenon called refraction. What is meant by refraction? The slight deviation of the light ray is called refraction. Let us have a small quiz on the above topic. Which phenomenon is observed in lenses? I will give you some time, you can guess the answer. The thing that is observed in the lenses is refraction. So the correct answer is option B. Let's go to the topic, types of lenses. Lenses are classified into different types, but the main important lenses are biconvex lens and the biconcave lens. So let's have some questions. Which two type of lenses are most important for us? Option A, biconvex and plano-convex, plano-convex and plano-concave, plano-concave and biconcave, biconvex and biconcave lenses. 5, 4, 3, 2, 1. The correct answer is option D, biconvex and the biconcave lenses. So let us go to the basic ray diagrams. There are three basic ray diagrams. The first basic ray diagram is rays parallel to the principal axis will pass through the focus. You can observe in the given diagram, when a ray is coming to the principal axis, here the principal axis is a line in the black color and the ray is in blue color. When a ray is coming parallel to principal axis, when it touches the lens, it passes to the focus. In convex, you can observe that it is coming parallel and passing to the focus F2. In concave, it is coming parallel. It is dispersing away. When we deviate it back, it passes through the focus 1. So let's go to the next basic ray diagram number 2. It is opposite to the basic ray diagram number 1. Rays passing parallel to the principal axis rays parallel to the principal axis will pass through focus with the basic ray diagram 1, and rays passing through focus will become parallel to principal axis is the basic ray diagram number 2. You can observe it in the given figures as explained before. Let us go to the basic ray diagram 3. Rays passing through optical center will be remained undeviated. When the ray passes through the optical center, there is no deviation in the light ray. You can observe it in the given figure. Let us have a small quiz on the above topic. In both convex lens and the concave lens, a ray passing through the ray passing through optical center will be options A, with little deviation, with lots of deviation, undeviated, and none of these. Your time ends in 5, 4, 3, 2, 1. Option C is the correct. It will remain undeviated. There are 6 basic ray diagrams for convex lens, 6 light rays, on 2 ray diagrams for concave lens. You can remind it in this way. Let us go to another small quiz. How many ray diagrams do we need to remember for convex lens? Your time ends in 5, 4, 3, 2, 1. Option C is the correct answer. There are 6 ray diagrams for convex lens. Let us have another small question. How many ray diagrams do we need to remember for concave lens? Your time and scene. 5, 4, 3, 2, 1. Option A is the correct. That means we have to remember two basic ray diagrams. Two ray diagrams. Basing on the basic ray diagrams for the concave lens. Image formation. That means first ray diagram for convex lens. When object is at infinity. What is meant by infinity? When object is so far from the mirror, all the rays will come parallel to the principal axis. What is the basic ray diagram number 1? When all the rays come parallel to the principal axis, they meet at the focus. You can observe it in the figure. Here we get a point-sized image. Okay, you can observe it. For an object at infinity, for a convex lens, the image is. I want to explain one more thing. You can call point-sized image as highly diminished image. Now you can answer this quiz easily. Okay. Your time and scene. 5, 4, 3, 2, 1. Option C is the correct. We get highly diminished image. Now let us discuss the second case. When object is at 2f, beyond 2f, that means it is back of the focus. Second focus. Okay. When object is at beyond 2f, one ray will passes parallel to the principal axis and it pass to the focus F2. And as per the basic ray diagram 3, one ray will pass through the optical center and remains undeviated. And they both meet at the point A dash. Here we get a real image. What is meant by real image? The image which is moved by the light ray is called the real image. And here we get real image, inverted image, and a diminished image, not highly diminished. It's only a diminished image. Diminished image means the image which is smaller than the given object. Here is a small quiz, you can answer it. For an object beyond center of curvature, that means beyond 2f, because center of curvature is twice of the focus. Center of the focus. In a convex lens, the image is. What I told about the image? Erect or inverted? Your time and scene. 5, 4, 3, 2, 1. It is an inverted image. Another small quiz. For an object beyond center of curvature in a convex lens, the image is. That means in the above case only. Real or virtual? So time and scene. 5, 4, 3, 2, 1. We get an real image. The next quiz is, when object is at beyond center of curvature in a convex lens, the image is. It is an enlarged image or diminished image. So time ends in 5, 4, 3, 2, 1. Time up. It is an inverted image. It is a third ray diagram. Image formation in convex lens. When object is at 2f, that means at center of curvature. As before ray diagram, one ray comes parallel and passes through the focus F2, and another ray will pass, as per ray diagram 3, will pass through the optical center and remains undeviated. Here both of them meet at the point A dash. Here we get the same sized image, and real image, and inverted image. So let's go to the small question. For a convex lens, if the object is at center of curvature or 2f, the image is, as we discussed it just before. Your time and scene. 5, 4, 3, 2, 1. It's the same sized image. Okay, another small question. For an object at center of curvature in a convex lens, the image is. So what time and scene? 5, 4, 3, 2, 1. We will get a real image. In most of the cases of convex lens, we get a real image. In some cases, it will be changed. Okay, let's have another small question. For an object at center of curvature in a convex lens, the image is. Your time and scene. 5, 4, 3, 2, 1. We'll get an inverted image. Image formation of convex lens. The next ray diagram. An object is at between 2f and the center of curvature, that means f and 2f. An object is between f and 2f. As per the basic ray diagram 1, a light ray comes parallel and passes through the point f2 or the focus f2, and another ray, as per basic ray diagram 3, passes to optical center and remains undeviated, and they meet at the point A dash. Here we get an enlarged image. That means the size of the image is larger than the size of object. There are also real image and inverted image. So here you have a quiz. For an object between center of curvature, it means 2f, and focus in a convex lens, the image is real or virtual? Your time and scene. 5, 4, 3, 2, 1. We get a real image. Option A is the correct answer. Real image. Okay. For an object between center of curvature and the focus in a convex lens, the image is, that means between 2f and the f. We get an inverted image or erect image. What is the answer for the above question? Your time and scene. 5, 4, 3, 2, 1. Get an inverted image. Another small question. For an object between center of curvature and focus in a convex lens, the image is enlarged or diminished. For time and scene. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Timer. We get an enlarged image. Let's go to the next image formation in a convex lens. When object is at the focus, as per the previous ray diagram, basic ray diagram number 1, a ray comes parallel and passes to the point f2, and another ray passes through the optical center and remains undeviated. Here we get an real image, inverted image, and highly enlarged image. Here the image is formed at so far away from the object. Okay. So let us have a small question. For an object at focus in a convex lens, the image is. What is the nature of the image? When the object is at the focus in a convex lens, Your time and scene. 5, 4, 3, 2, 1. We get highly enlarged image. Option C is the correct. For an object at focus in a convex lens, what is the nature of the image? Is it real or virtual? When the object lies at the focus of a convex lens, what is the nature of the image? Your time and scene. 5, 4, 3, 2, 1. We get a real image. When for an object at focus in a convex lens, the image is either inverted or erect. What is the nature of the image when the object is placed at the focus of a convex lens? Your time and scene. 5, 4, 3, 2, 1. It is a inverted image. Okay. The image formation, the next image formation in convection, it is somewhat different case. When the object is at between optical center and the focus, as per the basic ray diagram number 1, one ray becomes parallel to the principal axis and passes to the focus F2, and another ray passes through the optical center and remains undeviated. Here I will give some questions and then I will explain the nature of the image. For an object between F in focus and O optical center in a convex lens, then the image is either real or virtual. What is the nature of the image when the object is placed between focus and optical center? Your time and scene. 5, 4, 3, 2, 1. It is a virtual image. Okay. For an object at focus and optical center in a convex lens, the image is. Remember the diagram once. It is a erect image. For an object between focus and optical center in a convex lens, what is the nature of the image? Is it enlarged and or diminished? It is an enlarged image. We get an virtual, erect and enlarged image. Now let's go to the type or the basic ray diagram. Here the image is not formed. We extended the rays back and we make the light to make an object. What is meant by a virtual image? A image which directly does not formed by a light ray. When we deviate them back and make the light to form an image, here that is only happened. Here one ray passes through F2 and goes in a straight path, and one passes through the optical center and it also goes in another path. They don't meet at any point. Now we make them back, or we take them back and make them to meet at a point A dash and the place where the image is formed. Here we get an erect image. Is it erect? Yes. An enlarged image and an virtual image. Okay, let's go to the next. This is all the quizzes we have completed, and this is what the summary. Then this is the summary, means what about we discussed it earlier. Okay, position of the object. When object is at infinity, what is the position of the image? image is formed at f2, focus 2. And image is highly diminished or point-sized image. It is real and inverted. We discussed these all 6 cases are which we discussed earlier. You can take a screenshot or you can remember. When object is beyond 2f or 2f1, the image is formed at between f2 and 2f2. It's a diminished image, real and inverted image. When object is at 2f1, position of the image at 2f2, the image is same sized image and real and the inverted image. When the object is between f1 and 2f1, the image is formed beyond f2. It is an enlarged image and real and inverted image. When the object is at focus f1, the image is at infinity. It is infinitely larger. You can call it as infinitely larger or highly enlarged image as we discussed it earlier. Okay, and the image is real and inverted. When the object is between focus f1 and optical center O, on the same side of the lens as the object, it is as we discussed the previous case. This is different case as I told before. It is passing on the image is on the same side of the object on the lens. Okay, it is an enlarged image. It is virtual and erect. This last case is different from all the cases. You can observe it in the above chart. Okay. Now let's go to the concave lens. In the concave lens, when object is at infinity, that means at far away place, not appearing, at a higher distance, at more distance from the lens, the rays become parallel to the principal axis and gets deviated. In the convex lens, the images will be focuses. In a concave lens, the light ray gets dispersed or deviated. Here also the same thing happens. The rays are deviating. We take them back and let them meet at a point f1. So here virtual image is formed and the point sized image is formed. So image formation concave lens case 2. When the object is placed between optical center and infinity. So as per the basic ray diagrams number 1, it becomes parallel to the principal axis and deviates, not undeviated, and it deviates. As per the basic ray diagram 3, when it passes through optical center, it remains undeviated. So, in a concave lens, the rays are dispersing. We have to take them back. So, we have to take the ray which is parallel and passing away from the concave lens backwards and let it meet at the point f1. And both of the rays meet at the point A dash. And this is the place where the image is formed. This is a summary for the concave lenses. When the object is at the infinity, the image is formed at the focus f1. It is highly diminished or the point-sized image. It is virtual and erect. These cases we have not discussed. So let us go back and discuss about them. Okay, here it is a point-sized image. As we take the rays back, it is a virtual image and it is an erect image. Now, in this case, this is a diminished image. not highly diminished. It's only diminished image, and we have taken the rays back, so it is a virtual and it is a erect image. This is the summary of the above case. This is what we have. Thanks for watching this video. For more videos, subscribe my channel. For our latest updates, click the bell icon. If you want, you can take a screenshot of the videos or the pics. You need to remember like summary and the basic ray diagram and the rays formation on a convex and the concave lenses. Thanks for watching this video. For more videos, subscribe my channel. For our latest updates, click the bell icon.